So this is the trigonometric table in unrationalized form. That is, a root can exist in the denominator. It doesn't matter whether it is in unrationalized form or rationalized form, but in the unrationalized form, it just seems easier to remember. And most teachers do ask you to remember this, and you need to remember this because you might be asked to solve questions without using a calculator. So, in those cases, you will need to use these values without using a calculator, because if you use a calculator, your calculator would give your answers in rationalized form, and the examiner would understand that you used a calculator, which you did not. So the thing is, how do you remember this table? So these two columns, you'll have to remember them with graphs. Let's understand how. So at sign 0, we have a 0, and thus we have a 0 here. At sign 90, we have the graph at 1. So we have a 1 here. Similarly, at cos 0, the graph of cos is at 1. Thus we have a 1 here. And at cos 90, we have a 0. Similarly, at tan x, the graph intersects at 0. And at tan 90, we have an asymptote. So 0 and infinity. And infinity can correspond to not defined. So how do you remember this? For this, it is very important that you use your imagination. And before I start on making you understand how you use your imagination, just understand this fact. And always remember that sine 30 is equals to cos 60 and cos 60 is equals to sine 30. This is because of this identity. Now, and using this identity, you will also realize that why sine 45 and cos 45 are equal. So once I introduce this identity, let's move on to imagination. So you can get sine 30 as half by using a calculator. Alright? But just imagine a root outside. Now, every time you move one place to the right, I'll change the color. Every time you move one place to the right, the root moves one place up. I'll move to the right once again to reach 60. The root will move one place up again, and once it reaches the top, it becomes root 3, not root 1, because root 1 is 1. There's no logic behind this, there's only imagination. Then, how will we remember cos theta, the row of cos theta? So every time it works the other way around for cos. Every time you move one place to the right, the root moves one place down. So once it's down, once the root moves down, we have a 1 back in the numerator. We'll move to the right again, and the root is eventually out of the square. Now for tan, it is fairly simple. So we start by root 3. If you find the value of tan 30 in your calculator, you will most probably get root 3 over 3, that is in rationalized form. The question may specify whether you have to give your answer in rationalized form or unrationalized form, but for now, we'll stick to unrationalized form. So every time you move one place to the right for tan, you'll multiply by root 3. So thus we have tan 45 as 1. We move to the right once again, and thus we have root 3 for tan 60. Now, once you remember the trigonometric table, you might also use these values to find or solve advanced trigonometric functions. Let's say, for example, you are given sec 30. So sec 30 is 1 over cos 30. And cos 30 we learned is root 3 over 2. So we have 2 over root 3. Root exists in the denominator, and thus this is in unrationalized form. If we were to convert this to a rationalized form, we'd multiply this fraction by 1, or like this, and we turn out to have 2 root 3 over 3, and this would be our final answer. And this is me signing off.